Next up, we have Erin Urquhart. She is my brilliant predecessor who left quite big shoes to fill, and she is now the NASA Earth Action Water Resources Program Manager. She also still remains involved with us at PACE directly as our PACE Program Applications Lead. Take it away, Erin.
Good morning, everyone. Before I get started, I want to just kind of thank Morgane first and foremost. Can we get a round of applause for Morgane? As someone who was hired to do this job in late 2019, and I was told, basically bring together a community, get them excited for a mission with data that don't exist yet. The excitement I can see today is real. And I will say that hosting an in-person workshop, kudos to Morgane, I avoided it for 5 years because this is so much work and there was a global pandemic going on. But I do kind of commend Morgane for pulling together this community. It just kind of speaks volumes to both on the science and the application side of the house, how excited people are to get their hands on this data and turn it into science and action. So thank you. So like Morgane said, I am here today as the PACE Program Applications Lead, and what that means in a sentence is that I'm here to advocate for applications at NASA headquarters. So in addition to flight, in addition to technology and research, our applications program for PACE is robust, and so I advocate for this mission at headquarters, make sure that it remains not only my favorite mission, but everybody else's favorite mission. So I just wanted to get started and talk a little bit about kind of applications, decision support tool, and action. So the big question comes is how do we transform all this earth science research into actionable, innovative decision making that benefits society? And in my opinion, the key to unlocking this really comes in 4 different components. The first one, and a lot of kind of what folks are doing in this room, is leveraging Earth observation data grounded in sound science and research. That means using satellites, remote sensing technologies to gather precise, near real-time information on kind of our Earth's resources. The next one is to collaborate with communities, and that's something that's really kind of the bread and butter of our applications programs. That means engaging with local, regional, state, and international stakeholders to tailor solutions to meet their unique challenges, ensuring that the innovation and the decision support tools that we develop are meeting these needs. The next one is to really integrate cutting-edge technology. This can include, innovations, emerging technology like AI, machine learning, advanced forecasting, to really improve the accuracy and the timeliness of the data that we're going to get from PACE. And then lastly, kind of, the big reason that I'm here is now to take all of that and turn this data into actionable insights, converting these complex data sets into easily understandable, accessible, and digestible information so that we can create decision support tools that help inform policymakers, resource managers, and communities. So if we bring these elements together, we can really start to transform the scientific research into practical, real-world applications that can solve pressing environmental challenges. So the first bullet that I had there was leveraging remote sensing data and satellite-based data. So we can't be a NASA presentation without showing our Earth fleet. So NASA has about 70 existing or upcoming Earth observation satellite fleets. And what I can say that's exciting for a lot of people in this room, and that maybe that first bullet, oceans, is that over 70% of this fleet can address water and can address oceans. So I run the Water Resources Program. I might be a little biased, but very excited kind of for PACE and kind of this next generation of sensors that are being launched to support these types of environmental challenges. So thinking about kind of that fleet, NASA really does cover kind of the entire Earth system science. And so all the way here on the left, we have the solid Earth. So this is where I'm talking about aerosols, surface composition, gases, surface deformation. Then we go to the water cycle. That's instruments that provide information on precipitation, snow ice albedo, groundwater, surface water, soil moisture. Then we move into these terrestrial ecosystems. This is where we can get data from NASA looking at vegetation health, phenology, plant type, ecosystem structures and health, something that we mentioned that our colleague Fred is developing to kind of looking at what's going on across vegetation communities. And then lastly, we have this land-sea continuum. And this is where we start to get data kind of from missions like PACE. We can look at phytoplankton, we can look at algal blooms, we can look at sediment, coastal sea level rise, oil spills, and things like water quality. So zooming into PACE, and you're going to hear this over and over throughout the day, is NASA PACE data can provide information on water quality, atmospheric composition, air quality, cloud data, land surface data, and vegetation indices. But when people ask me, why do we have applications programs? Why do we have the Earth Action Program? It's because if you look at the left side, just because you get net CDFs from OCI, HARP2, and SPECS 1, that does not mean that you have use of PACE data in decision making, in resource management, benefiting society, economy, and the environment. So at the basic level, when people ask why do we have these programs, it's really that space in between. It's taking research data and transforming it into insights that inform action for practical solutions that meet all of our everyday needs. So if you've been kind of in the NASA space in the last 10 months, the NASA Earth Sciences Division recently released its new strategy, and it's called Earth Science to Action. And this strategy taps into the Earth Science Division end-to-end capability as an open enterprise to incorporate innovative scientific discovery, as well as emerging needs to accelerate the use of Earth science information to inform the next iteration of programs, missions, and initiatives. And I'm not going to belabor this Earth Science to Action strategy. If you want to find it, you can read it. It's multiple pages. But at the high level, the objectives of this strategy are to first and foremost, holistically observe, monitor, and understand the Earth system. And then secondly, to deliver trusted information to drive Earth resilience activities. So I apologize for the NASA folks in this room if this is a triggering slide to you. This is what we call the Earth Action Pyramid, Prism, a lot of different words. But basically, this is a visual representation of the Earth Science to Action strategy. So at the bottom level, we have kind of NASA's reason to be. It's this foundational knowledge, technology, missions, data. This is where all the science, this is where our flight programs, our Office of Technology, everybody lives. This is kind of, we can't do what we do in terms of action and applications without the foundation level of basically data. As we move up, we start to think about, this is where we understand Earth system science. This is applied research. Then we move on to actually turning this information into solutions so that we can deliver societal benefit. And then at the very top of this prism is public understanding and exchange. So because that's a lot, I like to kind of go through these and put them into kind of terms that I understand. So at the bottom, you can think about this as knowing. As we move up, we're learning about the Earth system. Then we're doing something with this data. We're turning it into action. And then at the very highest level, we're teaching. Another way, because I know there's a lot of modelers in the room, you can think about this foundational level as this is where you're building the models. Then you're improving your models. Then you're using the models, and then you're transitioning and sustaining these models. So within Earth Action, which is a little confusing, so we have the Earth Science to Action strategy, which is the Earth Sciences Division strategy. Within that, we have the Earth Action Program, which used to be called the Applications Program. The motto there is, sorry, let me step back. The most important part of this is called the virtuous cycle. So we have this arrow that takes everything and iterates it back down. So everything that we're doing throughout this is constantly being fed to the bottom. So the information that we're learning from communities, through user needs assessments, through engagement, through teaching, we're taking all that information in terms of what the community needs, and we're taking it back throughout. And while it looks like one big arrow, I see this as hundreds of arrows. Every bit of information that we get about how a user is going to use data or access data, if there's an issue, we take that right back to our data systems. We let people know that we can improve our processes at NASA based on the information we're getting from the communities. So what do we mean by action? So the definition of action is accelerating the use of Earth science to support policy and decision-making for society's well-being. There are kind of three mottos of the Earth Action Program. The first one, which I'm going to talk a little bit more about, is to be user-centered. And if you were involved in kind of any of the pre-launch applications activities for PACE, you participated in a lot of kind of needs assessments, talking about what kind of information you need to get your job done, basically just making sure that everything we're doing with PACE is really user-driven so that we can provide data that is kind of addressing your needs. So tailor efforts to meet user needs and requirements, both on the application side as well as the data requirements. The next one is building bridges. This is building bridges across NASA teams, divisions, interagency partners, international partners, to make sure that we're not just working in silos, but we're working across to really meet NASA's mission. And then lastly is scaling. So taking existing capabilities, applications, algorithms, models, decision support tools, and scaling them. More recently, we've been talking about scaling horizontally and vertically. And the best way for me to kind of represent that is horizontal scaling is thinking about taking something and making it more. More users, more regions, more applications. And then vertically is making it better. So new data. So if you have something that was running off of Modis data, integrate PACE data, make it better. More CPU, more data processing. So that's kind of how we think. So the Earth Action Program, it's all about being user-centered, building bridges, and scaling. So I want to go back to this. I added a pretty picture of some chlorophyll off the coast of California. Like I mentioned, we can't just go from a NetCDF file from PACE and turn it into sustained decision-making that is forming policy and society with PACE. There's a lot of steps in between. And so for the rest of the presentation, I kind of want to dig into that in between. So at the heart of the NASA Earth Action Program is that human-centered, user-centered approach. Regardless, the biggest difference between applications and Earth Action and research is that within the Earth Action side of the house, everything we do starts with the people themselves. We work closely with partners, we work closely with communities to really understand unique needs, gaps, and challenges. And this partnership between NASA and really the communities of users around the globe is what leads to supporting NASA's mission in supporting global resource needs. So some examples of that, and I hope I'm not stealing thunder, but one of the ways that PACE has done this over the years is to be user-centric is right off the bat, like Jeremy mentioned, we support an applications program. And PACE was one of the first mandated pre-launch programs to have a formal applications program. Other missions have had application programs, but there's never been a directive and kind of support to really get this off the ground pre-launch. So one of the things that this program did is it launched an early adopters program in early 2020. And so these are some folks, and I don't know what the number is at now, but these are folks that worked with the PACE mission pre-launch to understand needs, to develop kind of innovative ideas for applications of how they were going to use PACE data, to sit on hours of calls with us about talking about what do you need, to connect with our science and applications teams. So these are folks at the ground level that we engaged with from 2020 all the way to present, and this is becoming a new program to understand needs for applications to use PACE data. The other aspect of that is that second level up, it's third level, solutions and societal value. So across NASA Earth Action, there's a bunch of different programs that a lot of you probably have participated in that support and provide resources to develop decision support tools and solutions using NASA data. So you can see a lot of different programs. I want to point out all of the programs that PACE has relevancy for, which is really exciting and pretty unique. One of the most amazing things about selling PACE pre-launch is that PACE touches so many different aspects of society. That's rare. I've now learned, now that I'm at headquarters, is that not every mission can really talk to all of these different kind of complex challenges that society faces. So PACE data is informing health and air quality, our ecological conservation program, my program, water resources, specifically water quality, our climate resilience and community action program, capacity building, NASA Severe, NASA Develop, NASA RSET. It's turning this data and building capacity for folks to use this data. Our disasters program, our agriculture program with our new vegetation indices. Energy and infrastructure, Earth Information Center. Kudos to the folks that work with the Earth Information Center to get Jeremy's face at the Smithsonian so people can kind of see what NASA's doing. And then lastly, one of our newer programs, the wildland fires, thinking about kind of the aerosolization and the fire products that were shown earlier and how that's going to inform wildland fire response. And I do want to note that all of these programs have money. Very important. So the big difference between the early adopters program and kind of these types of programs that I'm talking about is these programs, similar to a typical ROSES, we have ROSES cycles that support folks in developing applications. I can shamelessly promote that water resources, including water quality in ROSES 25, will be looking for people to use PACE data to start developing innovative applications to support society. And then lastly, in addition to kind of all of the capacity building things that Jeremy mentioned, the Help Hub, the different kind of workshops and trainings we've had, PACE was also one of the quickest, earliest, you can probably back me up on this. So we have, under our capacity building program, again, think about the top of the pyramid, it's that teaching, is we have a program called RSET. And this, I think maybe you had mentioned that you took the RSET training. So PACE just recently participated with Morgane's help in an RSET PACE training for water quality. Again, this is probably the fastest I've seen a mission RSET happen, so kudos to that. That happened a couple months ago. It was a 2-day training. Again, introductory for water quality, but how to use PACE data. And with that, there's a lot of opportunities to engage with us through the Mission Applications Program as well as kind of through the Earth Action programs. There is an opportunity this week at AGU to engage with Earth Action leadership. It's on Tuesday. So stop by, ask my boss all the questions that I don't want to answer. Tell them that you have problems with the I'm kidding. But we definitely recommend that you come if you have questions about this Earth Action program, the Earth Science to Action program, how you can get involved in applications at any level. Please do stop by. Yeah, and I think with that, thanks for being here.